Our next topic is going to be finding maxima and minima, finding maximization and minimization for functions of several variables. And the main point of this is that the derivatives are going to tell us about this. So the first derivatives and the second derivatives are going to tell us a lot of information about when a function with one output and several inputs reaches a minimum or a maximum. So here's a picture of the kind of thing that you might have seen from single variable calculus, where you want to find the maximum and minimum of a function. Here, there are a couple of points where the function's flat. Those points are points where f prime of x is equal to 0, and all of those are critical points, places where the first derivative vanishes. Now, some of them are local minima and local maxima. So this point here is a local maximum, because nearby, it's the biggest possible value of the function. Any other nearby values of the function are smaller. Way over here to the right, there are other places where the function gets bigger, but locally, in a little neighborhood, this function stays smaller than the value at that critical point. This one is not a maximum or a minimum, even though it's a critical point. Even though it gets flat, if I go to the left, the function gets a little bigger, and if I go to the right, the function gets a little bit smaller. This function down here is a local minimum, and this one here is also a local maximum. But it's also a global maximum. This is the absolute biggest that the function gets. The function doesn't have a global minimum on the inside. Here, this is a global minimum. It's the smallest possible that the function gets. And so the theme of doing maximization and minimization problems in single variable calculus is you have to check all of the places where the first derivative is equal to 0. Some of them are going to be local maxima and minima. And you also have to check the boundary, because the maximum or minimum of the whole function might be on the boundary of the region rather than being on the inside. So that's the same thing that we're going to have to do with multiple variables. In our case, in this case, the first derivative test tells you that a local maximum or minimum has to happen at a critical point where the first derivative is equal to 0. The second derivative test is a little bit more refined. It tells us, is a critical point a local maximum or a local minimum, or are we not sure? I always get a little bit confused about the second derivative test, so it's worth remembering it. So if the second derivative is positive, that means that our function is happy, that means that it's making a smile, and that means that at this critical point, we're actually at a local minimum. I do not recommend trying to think about it as being backwards. Here, if the second derivative is negative, the function is curving downwards, it's sad, and our function is at a local maximum here. So we have to have a first derivative test, we have to have a second derivative test, and we also have to check the boundary to see where the global minimum and maximum are.